That's a true fact.
Today's the oh my gosh. Tomorrow is tomorrow May?
May 1st. Oh my gosh.
Unbelievable. I'm not joking. I don't joke about the calendar.
Don't ever do it. I hate mouth noises. Stop. Stop.
I'm done. So yeah, there's a lot going on here today. There are, as far as I'm concerned, there's 3 levels of log equations. We're going to tackle the first 2 today. There's some of them create quadratic equations, and there's A, I wouldn't do that to you, and B, I just don't think I could fit all that in. So I have 12 examples. I think we'll roll through the first 6. I think I'll be surprised if these take longer than about 10 minutes, these first ones. Um, so there are some properties that I don't want to say out loud yet. So when we get through the first 6, you don't need any log properties for the first 6 examples. Before we embark on the second half of this, I'm going to have to do a little detour and show you a couple of just basic fundamental properties of logs. I used to spend like days on properties of logs, and I just don't have the time for it this year. So we're just going to kind of throw it in sort of organically and hope that it goes well. So fingers crossed. But the first 6, you won't struggle with these at all. So let's start copying these down. First one is 8 times log base 3 of x minus 11 equals 21. So for problems that look like this, what I want you to take note of, because I think it's part of being good at math is identifying a problem and saying, like, what am I up against? This is important that in these first 6 examples, there's only going to be 1 log. That will change on number 7, okay? So because there's only 1 log, then our approach is very simple, and it's just simply to get the log by itself. We're going to treat this thing in the red box as our variable. It's not like a variable, but we're going to think of it like that, and we're going to use all the algebra knowledge that we've acquired to just say, fundamentally, can I just do stuff to get that by itself? And the answer is, of course I can. So if you think about get that by itself, you would add 11 to both sides first, right? So our next line down is going to say 8 times the thing we're trying to get by itself equals 21 plus 11, which is 32. So again, that's just rudimentary, basic pre-algebra sort of thinking. Add 11 to both sides. You've been doing that since 6th or 7th grade. How do we finish the job and get the log by itself? We divide by 8. And so the log is still just kind of sitting here waiting for us to be done messing around. And then 32 divided by 8 is 4. And what log equations boil down to at the end is just the water cycle. And I've said it 100 times and I'll say it 100 more. This is just where you need to embrace the idea of base to the lonely guy equals argument. That cycle over and over again is what enables us to take these out of Logville and put them into Workableville. So if I take the base 3 and I raise it to the power 4, I will set that equal to x. So my equation, and normally I wouldn't show this next step because like the end, it's already done. But just for your notes, I want you to see it, that it's going to look like 3 to the 4th equals x. But you see that the algebra it's done, right? I mean, the x is by itself, so the equation has been solved. The only thing that I kind of didn't skip over was that I need to simplify now, right? What's 3 to the 4th power? 81 is correct. So for this log equation, we would say that x equals 81. Now, with log equations, we do have to be aware, and this is going to be now something that's with us for the rest of this week and the first couple of days of next week, is we have to now be cognizant of the fact that logs cannot have negative arguments and they cannot have 0 arguments. So if I had gotten an answer like x equals -2, then I would say that this equation has no solution. Because if you put a negative number where this green arrow is pointing, you would understand fundamentally that log base 3 of like -2 doesn't make any sense. Like there's nothing that you could raise 3 to as a power to make it equal -2. So what you need to make note of mentally, physically in your notes or both, whatever, is that the argument of a log cannot be a negative number. Okay, that's very, very important. And it also cannot be a 0. So arguments of logs cannot be negative. They cannot be zero. But in this case, I've got no issues with 81. So I'm going to put a box around this, call that the solution, and I'm on to the next one. And I don't know that we're going to see any today that have extraneous solutions, the kind where you get them and you go, hey, that guy's no good. But just in case, I want to, I'll keep us looking at that every time. And you remind me if I forget that if we get an answer, we don't just want to hastily move on and put a box around it. We want to say, maybe it's a bad guy, but this guy's just fine. So 1 down, 11 to go. Any questions about that? All right, these next 5 should fly pretty quick. They get tougher just because at the end there's a little bit more loggy work we have to do. But the next one is -9 log base 4 of x plus 13 equals 10. So like the approach we take isn't going to be any different, but the ending is significantly harder just because you've got to really know how to evaluate logs and how to look. That's maybe the right way to say that, how to work with like negative exponents and things like that. So anyways, let's fundamentally do what we need to do first. So we're going to subtract 13 from both sides. That's going to leave us with -9 times the thing we're trying to get by itself equals -3. And then we're going to divide both sides by -9. And that's going to leave us with thing we were trying to get by itself equal to, what is -3 divided by -9? It is positive 1/3. You cannot divide 3 by 9 and expect to get a whole number because 3 is smaller than 9. So we're going to be dealing with a fraction in this case. So when we think about the solution of this, and I'll write this one out again, we're going to just water cycle it. I'm not going to draw the little purple water cycle every time, but it's base to the thing over there equals argument, like over and over again. It never will change. So we're going to say 4 to the power of 1/3 equals x. So the question's over, but we're not going to be allowed to leave our answers with fractional exponents. So do you remember what another way to write 4 to the 1/3 is? It's the cube root of 4. Very good. And that'll be huge today. Remember that when you have a fractional exponent, the bottom of the fraction indicates the type of root you're going to do. And the top is, if it's a 1, it doesn't matter. If it's something else, we'd need to put a power in there somewhere. But since it's a 1, it's irrelevant. So like Kane said, I'm just going to say, okay, so this is over x equals the cube root of 4 done. And that's what I would submit as my answer. Good so far? All right, 2 down, 10 to go. Oh, I got a straggler. Whoop, not anymore. -15 times log base 2 of x equals 10. I'm going to start saving us some time. This is a long lesson, and I just don't want to. In fact, I might even just start getting the log by itself for you. You understand at the beginning what the 2 steps are going to be, right? Add or subtract something away, divide something away, because the goal is always get the log by itself. So I might just start skipping that beginning part. So I still save the division for us here because I think that some people panic about this. So if we divide both sides by -15, then we're done with the setup. What is positive 10 divided by -15? It's negative. No, 2/3. If you think of the fraction 10 divided by 15, divide them both by 5, that's where you get 2/3 from. And of course, it's negative because we learned that in like 6th grade, right? That a positive divided by a negative. So here we go again with just water cycle it out. And then there's always going to be some math that you have to understand how to do, how to like simplify or rewrite things when you get done. So our answer in its unacceptable, completely unacceptable form is that x equals 2 to the power of -2/3. So that's a double strike. You get double gooned on points if you leave an answer like that. A, because we don't want negative exponents, they're bad. And B, we don't want fractional exponents. So that exponent's a double whammy. So we're going to put all of our knowledge, we know this, we've acquired this knowledge, that the first thing that's going to happen is we know it's going to be 1 over something. The negative exponent, you'll recall, we learned this last week or the week before, negative exponents make us move things downstairs. Right? And then how are we going to evaluate? I'll go off to the side here. 2 to the power of 2/3. What does the 3 down here make us do? Make a cube root, good job, of 2 to the second. So I'm just going to put 4. The top number of a fractional exponent is the power. The bottom is the index, the flavor of the root that you're going to build. So that would be how we would submit that answer. 1 over the cube root of 4. Okay. Any questions there? All right, let's go again. And this time I'm just going to get the log by itself. I don't see the point in making us do all that initial stuff. So let's just get right to it. We have log of x equals 1/2. So there was, I had some stuff where we had to add and divide, but you get all that. So there we are. We made it to the end, and now it's time to water cycle this out. What's the base of this log? 10. Invisible logs, log bases are 10. So my answer is going to be x equals 10 to the power of 1/2. But again, that is not acceptable. How do we rewrite 10 to the 1/2? The square root of 10. Good. And some people would say, where'd the 2 go? And it's like, well, I understand your question, but the 2 implies a second root. And with second roots, we generally don't need to put a 2 there. Like math people understand that a root with no index is just assumed to be 2, right? So it's the second root of 10. So I would not put the 2 there. Bad juju. Ready for another one? Okay. Next one, again, I'll just do all the initial setup work for us. We have log of x equals, what's that going to be? Negative 1/3. All right, so I subtracted and divided and did all that stuff for you, and boom, here we are. We made it to the end, and now we're going to use our water cycle. So what's our answer going to be? X equals what? And don't worry about skipping steps here. I just want to know when it's raw form, what does it look like? 10, that's what I wanted to hear. 10 to the negative 1/3. And again, this answer is double bad, right? Bad number 1, negative. No. Bad number 2, fraction. No. Bless you. So we want to fix that on both accounts. And what's the first fix that we acknowledge? Put it on the bottom. So we have x equals 1 over some stuff. Just, kind of get it ready to go. What kind of root are we going to make? A cube root of 10 to the first power, which is, of course, just 10. So 1 over the cube root of 10. Still good? All right, I have one more on this side of the note card, and then we'll head over to the harder stuff. Okay, so I hope these aren't kicking your butts. This is log base 8 of x equals, what's that going to be? 8 negative 2/3. Step 1. Yeah. And I hope I'm not going too fast, but I'll just draw it one more time in case anyone's feeling a little leery right now. I just keep doing this thing to the power of this thing over here equals this thing over and over again. And I'm switching sides because I like my x on the left. So rather than writing 8 to the whatever equals x, you'll notice a few problems ago, I just started writing x equals. I like it better that way. So it's x equals, I think what Kaysen said was 8 to the power of negative 2/3. And that's another exponent that I can look at and give it the double bad label. It's a no, and then it's a no again because it's a negative, strike, fraction, strike. So we fix it. So first thing we're going to do is we're going to move all of the junk to the bottom and put a 1 on top. What flavor of root are we going to build? A cube root, right? And then I'm inside going to put 8 to the second power, which is 64. Yeah, 8 to the second power is 8 squared, 64. Yes, and so good observation. And I wanted this to be the last example on this side because I don't want you to think that we always just leave our answers as they come. We have to be aware of the fact that sometimes, the word that you've been hearing since 5th grade is simplify. And simplify has always meant the same thing. It means to keep doing math reasonably until you just don't have any more math to do. And good observation in this case that the cube root of 64 is 4. And so the answer to this problem is not what you see here. The answer to this problem is 1/4. Nice and simple. So watch out for math that can be done along, like at the end. Like don't leave a cube root of 8 in your answer because that's 2. Don't leave a square root of 25 if you get one because that's 5. Stuff like that. Like you want to fix things as you go. Do you have any questions on that left side of my note card? Okay. So for this part, hopefully you feel good about that. I got to hit you with a couple properties of logs. Let me just put the first problem up here because it would be better for you to sort of learn this like in context, like in the wild. So the first thing you're going to notice now, and you're going to want to draw a line in your notes to separate this because something is going to change and it's massively significant. If you go back in time like 12 minutes, the first thing I asked you to notice about the first 6 problems was what? There was only one log. Good job. Great memory. And this one, there's 2. And now all the last 6 examples are going to be like this. There's going to be 2. So let me say this first. You cannot apply the water cycle if there's 2 logs. The water cycle, that conversion that we do with the little purple arrows, that only works if you have a single log. Which begs the question, like, am I hosed? Am I out of luck? And the answer is no. There's a very simple property in algebra that allows us to do something that we call, you need to know this word. It's called condense. What you have to do is take 2 logs and condense them into 1. And I'm going to do this, and then I'm going to just ask you what you think I did. Like, I'm going to do this correctly, okay? Sometimes I mess up on purpose and have you find my boo-boo. I'm going to do this one correctly, and you're going to crack my code and tell me how I did it. What kind of witchcraft did I use? It's like magic. And if you spot it, you just learned a very simple and usable property of logarithms. Anyone want to guess where I got 6x from? I took the arguments, 3x and 2, and I multiplied them together. So when you condense 2 logarithms with a plus sign in the middle, then you condense it into a single logarithm where the new argument is the product of the old arguments. And just like that, we've morphed it into a problem that would have been on the left side of my note card because now it's a 1 log. Okay. And don't worry, you get to practice because we have 5 to go after this. So say again.
What if your logs don't?
What a great question. If your logs are not the same base, then we have to do a base change formula, and that is not even going to happen today. So everything you're going to see today, excellent question. The bases will already be the same. If they're not, eventually I'll teach you how to do what's called a base change, and it's not really that hard. It's just annoying, and it's not a bridge I wanted to cross with you today. So all of the double log problems will have matching bases. Cross my heart. Okay. What's up? Do you have a question?
Plus in the middle to multiply it. Does that mean with the minus you would divide it?
Yeah, I mean, I can't even believe that you would just say that, but that's one of the best. I don't think anyone's going to say anything better than that all day, unless someone walks in and says, "Hey, your wife called, you won the lottery." That would be pretty awesome. But what Alicia just said, I hadn't expected you to make that observation, but it's like a perfect segue into the next example. But yes, she's exactly right. If this is a plus sign, we condense using multiplication. If the middle is a minus sign, then we condense using division. Excellent observation. Top notch. So let's finish this problem real quick because we still have to convert it and solve it. So we're going to take 4 to the third, which is 64. And we're going to say then that 64 must be equal to the argument of the log 6x. And unlike all those ones on the other side of my note card, this one's not done, right? You got to do a little rinky-dink algebra. How do we get x by itself? Divide by 6. So we wind up with x equals 32 thirds. Because you don't want to, like, you don't literally want to divide it out, right? We know that fractions are better. So we just reduce it and call it good. Good. All right. In this next problem, you're going to learn man, why did I write these in this order? I'm calling an audible on my note card. That was stupid. We're doing the 4th example second because what was I thinking? you're going to be faced with subtraction. So we're going to do log base 4 of 4x minus log base 4 of 2 equals 3. And this is just a stupid side note. If I don't say this, then I would be remiss. Delta math is going to add red parentheses like that. You can if you want to. I generally only package up the argument to my log if it contains more than one thing. So like I usually just, if I just have log of 2, I'm just going to put the 2 out in the open. But Delta encloses, I think, all their arguments in parentheses. So when you see it on the computer, it doesn't mean anything. It's just like maybe how they programmed it or someone's personal preference or something like that. All right, so like Alicia pointed out, great job transitioning us to this. This one has a minus in between the two logs, but we're still doing that word condense. So what is this one going to say, do you think?
Log base 4.
Log base 4 of 2x. Nice job. And as you'll see in some of the examples, that division doesn't always work perfect. So that's why this one had to go second, because I didn't want us to deal with like a fraction in this one just yet. But it came out nice, right? Argument divided by argument equals condensed argument. And then we just hit it with the water cycle. And that's that. So we're going to take 4 to the third equals that. So it's going to say 4 to the third, which is 64, equals 2x. So what does x equal? 32. Done. Still good? All right. In example number 3 on this side, you are going to learn the other property of logs for the day. And this is related to the most useful property of logs. It's kind of like the backwards version of the most useful property, but we don't have any real reason to use the other one today. So I'll keep it in the holster. So we're going to do log base 6 of 7x plus 2 log base 7 of 4 equals 3. I've asked you to learn a few things today. This is the last one. And then the rest from here is just practice with what we've acquired. So we'll have 3 examples after this one that you won't learn anything new, I don't think. It'll just be practice with acquired knowledge. So you ready for the last one? You ready to drink this in, write this down? Does anyone notice anything? I should just ask that first. The 2. If this 2 should be sticking out like a sore thumb. And maybe not, because we've only done 2. So maybe you wouldn't have enough like background yet to say this is someone new. Like maybe he doesn't look like an intruder to you yet, but he is bad news. You cannot condense, I'm saying this, you cannot condense 2 logarithms if either of them has a number in the front. Which begs the question, well, what am I supposed to do? And I present to you another property of logarithms, and it goes like this. And again, I'm going to write it down, and you're going to see if you can figure out how I got it. So log base 6 of 7x is going to stay the same. This one's going to become log base 7. Why did I do log base 7? I meant log base 6. I'm so sorry, you guys. Here I was promising Kennedy, and then I spazzed out and wrote a 7. What was I thinking? You see what I did? There it is. That is the next property of logs. And what Mari just said, in case you didn't hear her, is I took the coefficient, the number in front 2, and I just airlifted it up here. And I dropped it onto the 4 as an exponent. That's going to be, when all is said and done, if you go on and take college math class, that'll be the one property that you use 100 times more than all the other properties. And what it does is it enables us to move things around really in a slick way. It only works with logarithms, but you can take an exponent of an argument and move it down front, or you can take something down front and move it up top. And the reason we're moving it up top here is because, like I said, you can't condense 2 logs if there's a number in front of either of them. But we just solved that problem by just airlifting that 2 and dropping it up onto the 4. And now we're good to go. We got the green light. So it's time to condense. We can do it now because there's no numbers right here and right here. Green light. So we're going to have a condensed log of log base 6 of something equals 3. And what is that something going to be? 112x. But I have to ask, does everyone know how I got that? I multiplied the arguments together, right? So I took this argument, 7x, times this argument, 16, and 7x, 7 times 16 is 70 plus 42, 112. So there it is, the condensed, ready to go, ready to water cycle logarithm equation. That's a lot. But that's it, they won't get any harder than this, I don't think. So let's do this. Let's light this fire. So we wind up with 6 to the third, which is 216, equals 112x. And then it's just simple algebra. What do we do from there? Both sides by 112. So x is going to equal, I think those can both divide by 4, which is, I think they can actually divide. Let's start with 4 and see if it can go further. It's going to be 54 on top, and that's 25, 3, 28. So yeah, we can go another step. Let's divide them by 2 again. So we wind up with 27 over 14. So that would be the final answer for this particular equation. Some of your calculators will reduce fractions. I mean, I think most of them do anymore. If it was manufactured after like 2002, it'll probably do it. I can show you how. It just come see me later. But I mean, reducing a fraction is just division, division, division until you run out of stuff like that. That's easily the hardest one we've done yet today. Do you have any questions about that? Okay. Let me just have a second. I'm going to relabel my note card to make sure I do these in the right order later. Go. Next one. Hey, 3 to go. What are you doing? What are you singing? Singing Disney? All right, let's see what you've learned. What do we do first? Huh? Oh, yeah, you need an equation, don't you? It equals 0. My bad. Holy smokes. Okay, my bad. Now, what do you do first?
Take the 2 and make it an
Nice work. Airlift this 2 and make it an exponent on the argument. So, and you might find yourself starting to combine steps. Like as you go through the work, you get better at it. But I'm not going to do that right now. So we're going to have log base 7 of 9x. Like that one's just fine. Minus log base 7 of what? Absolutely. And now that we've gotten rid of the Clingiani number in the front, we can condense away. It's going to be divide. I heard you whisper. That's exactly perfect. Again, going back to Alicia's observation that a minus is going to lend itself to division. So we're going to condense into a single log base 7 of some fraction. Like, and this is what I alluded to earlier. Like division isn't always going to be like cute and pretty. Like you're going to get some bad stuff. Like in this case, we just get log base 7 of, 9x over 49. Not all division problems were actually meant to be really divided. Like 3/5 is just fine like it is, right? 9 over 49 is just fine like it is. Ready to move on? So it's time to convert it, right? Water cycle, call it whatever you want. Call it the loop-de-loop. It does not matter to me. It's a conversion though, and that's what we have to do. What's our next step going to say? So we're going to take 7. We're going to raise it up to the power of 0. And we're going to set that equal to the argument of the log. We should go on a little side journey here and just make sure you guys all know. Do you guys know what 10 to the 0 is? 1. Do you know what 8 to the 0 is? 1. Do you know what 7 to the 0 is? 1. Okay, good. Just to make sure we're all up to speed here. So when I cycle this up, 7 to the power of 0 really just equals 1. So it's 1 that equals 9x over 49. At this point, that's where it immediately morphs from being an algebra 1 problem or from an algebra 2 problem to an algebra 1 problem. No more logs, no more powers. It's just fundamental algebra. How would you solve that equation? I would multiply both sides by 49 as well, because fractions are just not allowed. So we kill that with multiplication, and then we're left with 49 times 1, which is 49, equals 9x. And then what's the final step? Divide both sides by 9. And I mean, we wound up with another, yeah, again, I don't want a decimal. So we're just going to say x equals 49 ninths. Yeah, stay away from decimals. It just is a matter of habit. I always go back and forth. Like if it was 5 over 2 and you put 2.5, no harm, no foul. But as a general rule of thumb, if you just avoid decimals always, then you never have to worry about, is it a good decimal or a bad decimal? Because they're all just in the gutter. All right, we got 2 more. Which one you want, the plus or the minus? Plus. Okay, so let's do log of 6x plus 3 log of 2. Let's do another one with an equal to 0. You guys have done a great job today. My spidey vibe is telling me you're getting this, and I'm almost done. I know I'm well past the time at which a person should keep expecting people to listen. So you're doing great. Step 1.
Take your 3 and make it.
Yep, airlift that 3 up to make it a power. So we're going to leave the first log alone as log of 6x. We're going to airlift the 3 up here, loop, up there. And what's 2 to the 3? Don't say 6. 8. Good. You okay? I'm still singing Disney, aren't you? Oh, okay. Let's condense. So we're going to have a single logarithm with an argument of what?
48.
Because it's 2 to the power of 3, which is 2 times 2 times 2. You okay? It's not. It's exponentiation. So when the 3 goes up there, it becomes an exponent. So this 2 has a new exponent of 3. It's not a multiplier. It's a power. Does that clarify? Kyla? Okay, awesome. All right, so if we condense this down into a single log, what's it going to be? Log base 10 of what? 48x equals 0. And this will look really familiar because you got another one with a 0. So it honestly, in this case, the base is irrelevant, as you know, but it's 10, just as a matter of principle. So we're going to say 10 to the power of 0 equals 48x. I don't know why I wrote that, because what's 10 to the power of 0? Yeah, that was like 7 seconds I can't have back. And then we divide both sides by 48. What's x? 148. Boom. Last one. Woo-hoo. Log base 2 of 5x minus 2 log base 2 of 2. There are too many 2's in this problem. Step 1, airlift. So we're going to go log base 2 of 5x minus log base 2 of 4. And then let's condense. What's it going to condense into? Log base 2 of what? Nope. It's a minus, so we have to divide. So it's going to be 5x over 4. So remember, plus condenses to times, minus condenses to divide. And now let's convert it over with the water cycle. 2 to the power of 1 equals, nah, 2. You made it. Next step.
Mhm.
By 4. 4, right? We want to multiply both sides of this equation by 4. Yeah, we always want to remove those denominators. So we wind up with 8 equals 5x. Whew, last step. X equals 8/5. Yep. So we have 7.5 minutes of class left. And I'm actually done. I didn't even know if I'd make it, but we made it. I'd like you to bust out your Delta Math. Let's see. And by the way, I mixed the left side of the note card, right side of the note card problems together. So you might get 3 easies, 1 hard, 2 easies, 4 hards. Like, I don't know. Delta's going to randomize it however the computer sees fit. So let's see if we can make a little chip in this today. And then obviously we'll work on them a whole bunch tomorrow. Whole bunch.
What kind of business?